Hey, as promised, we're going to do a few examples showing how to use our new definitions to compute tangent lines to some curves at some given points. And when I say we, I mean you. The first example will be to find the equation of the line tangent to y equals x cubed minus x at the point 1, 0. Before you start, let's notice a couple of things. First of all, this curve really does pass through the point 1, 0. When x is 1, you plug in 1 for x and you get 1 cubed minus 1, and that's 0, so y is equal to 0. So it makes sense to say, it makes sense that there is a tangent line at that point. And so in order to find the tangent line, we'll have to find the slope of the tangent line, and then we'll find the line passing through 1, 0 that has that slope. And before you start, we have two different definitions for the slope of a tangent line through a given point. And those definitions are as given here. The slope of the tangent line, or the line tangent to the curve y equals f of x at some point a, is the derivative of the function at a, f prime of a, which is either the limit as x approaches a of f of x minus f of a all over x minus a, or equivalently, f prime of a is the limit as h approaches 0 of f of a plus h minus f of a all over h. So in general, you can use either of these to compute the slope of the tangent line. And I would suggest that for this particular example, use the first definition. I think it comes out a little bit easier. So start with that first definition, the limit as x approaches a of f of x minus f of a all over x minus a, and see if you can find the equation of the tangent line to this curve at the given point. Pause the video right about now, start it back up when you're all done, and then we'll do it very quickly together. Okay, here we go. The a in this case is the x value 1. We're looking for the line tangent to the curve at x equals 1. And so we're looking for f prime of 1 will give us the slope of that tangent line. And that's the limit as x approaches 1 of f of x minus f of 1 all over x minus 1. All that's left is to compute these values, do some algebra, and then take the limit. F of x is x cubed minus x. F of 1 is 0, so we plug in those values. And we simplify and factor the numerator, and then you see that the x minus 1's cancel, and we just get the limit as x approaches 1 of x times x plus 1. And if you wanted, you could distribute and multiply those out and see that it's a polynomial. In either case, whether you do that or not, you can just plug in 1 to compute the limit. And we find that the slope of the tangent line is 2. We've answered half the question. We found the slope of the tangent line. We're looking for the equation of the tangent line. So we start with the equation of a line is y equals mx plus b. Plug in that the tangent line has slope 2, so y equals 2x plus b. And then all that's left is to solve for b, which we can do by observing that the tangent line passes through the point 1, 0, so x equals 1, y equals 0. And that lets us solve to find that b is equal to -2, which gives us our final answer to this problem. Y equals 2x minus 2 is the tangent line that we were looking for. Okay, that was our warm-up. It shouldn't have been too bad. This one, it's the same idea. It's just that the algebra is slightly trickier. Not that it's especially hard. You can do it, but you will have to do a little bit of work. Use either definition for the slope of the tangent line. Ideally, use both. Do it one way, and then when you're done, do it the other way. You should get the same answer. The algebra is similar, but different in both cases. We'll do it both ways in just a few moments. So pause the video, take some time, see if you can't work this out, and then we will do it together rather quickly. Okay, we're looking for the slope of the tangent line at x equals 2, so we're looking for f prime of 2. If we use the first definition, then we see that that's equal to the limit as x approaches 2 of f of x minus f of 2 all over x minus 2. Simplifying this expression, we get the limit as x approaches 2 of 1 over x minus 1 over 2 all over x minus 2. And here's where the fun begins. In order to make any progress, we have to combine those terms in the numerator, and to add or subtract fractions, you need a common denominator. And the common denominator in this case is x times 2, or 2x. Just like if you were trying to add 1/3 and a half, the common denominator would be 3 times 2. Well, here you're trying to add, or in this case subtract, x, 1 over x and 1 over 2. So the common denominator is 2x. And the usual trick for getting common denominators is you multiply each term by 1 in some clever way. We'll multiply 1 over x by 2 over 2, and we'll multiply 1 over 2 by x over x, and that will give us denominators of 2x in both of those terms. And once we have common denominators, then we can take advantage of that to combine them into a single fraction. 2 over 2x minus x over 2x is 2 minus x over 2x. Now we've got a fraction on top of a fraction, a mixed fraction, an improper fraction, I guess people call those. That's no good. Dividing by x minus 2, the same thing as multiplying by 1 over x minus 2. And so when you put it all together, you get the limit as x approaches 2 of 2 minus x over 2x times the quantity x minus 2. In order to make some progress here, you have to see the relationship between 2 minus x and x minus 2. Why don't we do that off on the side? And there it is off on the side. It turns out that negative x minus 2, after you distribute the negative sign, is negative x plus 2, which is the same thing as 2 minus x. So we'll rewrite the 2 minus x as negative x minus 2. And after we do that, we get the limit as x approaches 2 of negative x minus 2 over 2x times x minus 2. And you can see that the factors of x minus 2 cancel. And we're left with the limit as x approaches 2 of negative 1 over 2x. This is a rational function, perfectly well defined at x equals 2. And so to compute that limit, all we have to do is plug in x equals 2 to get the answer negative 1/4. So the slope of the tangent line is negative 1/4. And before we compute the equation of the tangent line, let's compute the slope of the tangent line once again using the other definition for the derivative at a point. Okay, same idea. We're still trying to compute f prime of 2. And using that second definition, f prime of 2 is the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. Simplifying this expression gives us 1 over 2 plus h, that's f of 2 plus h, minus 1 over 2, which is f of 2, all over h. And we're in the same boat. In order to make any progress, we have to combine those two fractions in the numerator. And in order to do that, we need a common denominator. And the common denominator is 2 plus h times 2. Which gives us this expression here, 2 over 2 times 2 plus h minus 2 plus h over 2 times 2 plus h all over h. Now that we have common denominators, we can combine these fractions. We have to be careful. We're subtracting the second one from the first one, so you have to subtract the entire numerator, that entire number 2 plus h, from the first one, which is to say that you absolutely need these parentheses here. In the numerator, we're subtracting all of the 2 plus h from the 2 there. We can simplify that expression some, and we also are in the situation where we have a fraction on top of a fraction. Dividing by h is the same thing as multiplying by 1 over h, so dealing with both those things at once. We're left with just a negative h in the numerator. 2 minus the quantity 2 plus h is just negative h. And when you multiply by 1 over h, you get negative h over 2 times 2 plus h all times h. Now the h's cancel, and we're left with a rational function that is perfectly well defined at h equals 0. So to compute this limit, all we have to do is plug in h equals 0. And that happily gives us the same negative 1/4 that we got when we computed the derivative at this point through the first definition. So no surprise there. So now we know that the slope of the tangent line to y equals 1 over x at x equals 2 is negative 1/4. Time to finish the problem by computing the equation of the tangent line. Once again, it's a line, so it's y equals mx plus b. We've just spent a lot of time and effort to compute that m is equal to negative 1/4. So we have y equals negative 1/4 x plus b, and all that's left is to figure out what b is. Well, for that, we need to know values of x and y to plug in. The problem only tells us what x is equal to. But if we know that what x is equal to, in particular x is equal to 2, it's very easy to compute what y is equal to because y is 1 over x. So where x is 2, y is 1/2. Giving us that 1/2 is negative 1/4 times 2 plus b. And solving that, we get that b is equal to 1. Which brings us finally to the answer to the question. The equation of the tangent line is y equals negative 1/4 x plus 1. Okay, you're certainly not going to have precisely those problems for homework, but you're certainly going to have problems that are similar to them, and hopefully some other interesting problems that require a little thought. Have some fun with the homework. Talk to you soon. See you in class. Bye.